Okay, now it's recording. All right, shh, gentlemen in the back. Yep, it's set on the board to pick it up. And as I was walking around, I mentioned it. So it's right there on my desk. Okay. So we're reviewing horizontal asymptotes. And I'm just going to repeat this because it wasn't recording before. Just ignore it. That's for the half day. They haven't changed it apparently. Horizontal asymptotes. I'm going to ask you to be quiet one more time while I'm recording this, and then I'm going to make sure to send it to some of your parents who were talking to me about it.
Staff, I apologize. Please do not dismiss students at this time. The bell schedule will be corrected.
Okay. So, if the numerator's degree is less than the denominator's degree, it's y equals 0. If the numerator and denominator's degree are equal, it's the leading coefficient over the leading coefficient, the top of the bottom. If the numerator is greater than the denominator, there is no leading coefficient. Horizontal asymptote. Okay, so we're looking at this one. We just want to find the horizontal asymptote. If we look, do you see how there's no x value at the top? That means the degree is 0. There's no x. If we look at the bottom, we have one x value. We have one variable. Okay, that has a degree of 1. So if we look, our numerator and denominator, our denominator is bigger, which means it is y equals 0. Okay? Let's try number 5. We're just going to skip all the way to 5. I'm doing 5 because 5 looks the opposite. We've got x minus 8 over 6. So this one had a 5 on top. With this on the bottom. Now we're going to flip it over. Okay? So I've got my numerator. I've got my denominator. On the top, my numerator, my denominator. My numerator has a degree of 1. My denominator has nothing. So my numerator is bigger than my denominator, which means, what's the horizontal asymptotes for this? None. Okay, the numerator is greater than the denominator. Okay. Let's just try one more that's different. Let's look at number 9. We've got 5x plus 9 over x minus 6. What's the degree, if we've got a numerator and a denominator, what's the degree for the numerator? 1, right? There's no little squared or 5 or 3 there. It's just 1. What about the denominator? They're equal, which means it's the leading coefficients. So there's no number in front of x, so we know that's the same as 1. So it's y equals 5 is my answer.
Whoa.
Okay. All right. Let's look at 12. Let's look at 12. The problem with 12 is these things are not in order. Okay? So with 12, the first thing we could do is change them so they're in order. We could have negative 9x to the 4th. And by order, I really mean that the degree is the biggest degree to the smallest degree for the top and bottom. Okay? So we have negative 9x to the 4th plus 5x to the 3rd plus 2x. And on the bottom, we have 2x to the 4th minus x plus 3. Okay? Now, if we're looking at the numerator and the denominator, this one has a degree of 4. This one also has a degree of 4. So they are equal. So my horizontal asymptote is y equals negative 9/2. That's my horizontal asymptote. Is this horizontal asymptote starting to make a little more sense? Because I think this and end behavior is where you guys are most lost. Yes, Jordan?
Oh, wait.
Okay. So we talked some about horizontal asymptotes again. Now we're going to talk about slant asymptotes, or oblique asymptotes is what we usually call them. Okay? So this is where we have to use Friday's knowledge of how to divide these polynomials with setting it as a slant asymptote. Okay, so I'm going to say x divided by x squared minus 4. Okay, everybody with me so far? We're not having side conversations or playing on our phone. We're actually writing down what I'm writing down. Okay. X goes into x squared, x times. X times x gives me x squared. We subtract. We have to pull down the negative 4. Anything times x, is that going to give me negative 4? So that's my remainder, right? My remainder is negative 4 over x. When I'm talking about the slant asymptote, I'm going to ignore my remainder. So I'm going to say my slant asymptote is y equals x. Okay? Why don't you guys try number 14?
Number what?
14, right here next to it. Number 14. Shh. So trying it is not having a conversation, not deciding Miss Murphy's not speaking right now, so I can just go ahead and talk. It is actually trying it because you do have a quiz coming up. Alright, there's a lot of talking, so I'm assuming you're done. So let's go ahead. We went x divided by x squared plus 5. Should have been pretty straightforward because it's very similar to the previous problem. X times what gives me x squared? Gentlemen in the back, I need you to be quiet now. Shh. Thank you. X times x is x squared. We subtract, we don't get anything. We bring down the 5. We have a remainder of 5 over x. So we can just say y equals x is my slant asymptote. Okay. Number 15. We've got 2x squared plus 1 divided by x. X goes into 2x squared, 2x times. 2x times x is 2x squared. Okay. We subtract and we get rid of it, but we have that 1. So we have a remainder of 1 over x. So y equals 2x. Okay. So with 16, we have 1 minus x squared. I'm going to change this to negative x squared plus 1 over x. So it doesn't matter. I just switched which order. I think it's going to be a lot easier now to do it. Negative x squared plus 1 divided by x. X times what gives me negative x squared? Negative x. Negative x times x is negative x squared. We change the signs. We get a remainder of 1. So my slant asymptote is y equals negative x. Okay. Let's turn it over. Let's let it get a little bit more complicated.
Oh my.
We're going to look at number 17. Okay, this is impossible to read on mine. So this is what it says. It says 2x to the third plus x squared minus 8x minus 4 all over x squared minus 3x plus 2. This is what f of x equals. Okay. Okay. So we're going to take 2x to the third plus x squared minus 8x minus 4. And we're going to divide it by x squared minus 3x plus 2. Okay? squared times what gives me 2x to the third? 2x. So I've got 2x times x squared gives me 2x to the third. Then I have to take 2x and times it by negative 3x. That gives me negative 6x squared. And then I have to times it by 2. 2x times 2 is positive 4x. Then I'm going to change all of my signs. And I'm going to add straight down. These cancel. But x squared and 7x and 6x squared is 7x squared. Negative 8x and negative 4x is negative 12x. And then I have to bring down my negative 4. Okay, what times x squared gives us 7x squared? 7. Just 7. 7 times x squared is 7x squared. Now I have to times that 7 by negative 3x, giving me negative 21x. And 7 times 2 is 14. Now I'm going to go through and I'm going to change the signs. And I'm going to add straight down. Do you need me to zoom in a little bit?
Yes.
Is that better? Okay. Negative 12 plus 21 is 9. Negative 4 and negative 14 is negative 18. So this has a remainder of 9x minus 18 over x squared minus 3x plus 2. But I don't have to worry about the remainder when I'm doing my slant asymptote, which is 2x plus 7. Okay? All right. Why don't we try one more? Let's look at number 19. Let's look at number 20. Okay? We've got x squared over 3x plus 1. Okay? So, I want to go 3x plus 1 divided by x squared. What times 3 is going to give me x squared? Right? If we times this by x, so let's just try this. X times 3x is 3x squared. X times 1 is x. If I subtract this, it's not going to give me 0, right? It's going to give me negative 3. So this doesn't work. So no oblique or slant asymptote. Okay? All right. So, why don't you guys work on the other page is going to be your homework. Okay? It's got 10 problems here. I think they're all legible. Where you're going to divide and you're going to work. It's more of the kind of homework that you worked on last night. I mean, Friday night, Thursday night. So you're just going to solve all of these. All right, I'm going to stop the recording.